Hello students, today we will be studying about KMnO4, potassium permanganate. So potassium permanganate, that is KMnO4, is a violet colored solid. The intensity of violet color decreases when we dissolve it in water. So aqueous solution of KMnO4 becomes purple in color. So here we will be studying about preparation of KMnO4. So if we talk about preparation of KMnO4, KMnO4 is prepared by fusion of MnO2, that is manganese dioxide, or we say pyrolusite, with an alkaline metal hydroxide such as KOH, and an oxidizing agent such as oxygen or potassium nitrate. So this produces dark green colored K2MnO4, that is potassium manganate. So in the first step, from manganese dioxide, when fused with KOH and oxidized with oxygen, we are getting K2MnO4, that is potassium manganate. So if you balance the equation, it will be 2MnO2 plus 4KOH plus O2 gives K2MnO4, 2 times K2MnO4 plus 2 times H2O. Now this dark green colored potassium manganate, that is K2MnO4, in this K2MnO4 the oxidation number of Mn is plus 6. So this K2MnO4 in the second step undergo disproportionation reaction in the presence of neutral or acidic solution such as sulfuric acid to form KMnO4 then MnO2 then K2SO4 and H2O. So here we will take 3 times K2MnO4 plus 2 times H2SO4. So it produces 2 KMnO4 plus MnO2 plus 2 K2SO4 plus 2 H2O. So in this way we will obtain potassium permanganate having Mn in the plus 7 oxidation state. So here K2MnO4 is having manganese plus 6, which undergo oxidation to plus 7 as well as reduction to MnO2 having Mn in plus 4 oxidation state. So these are the two steps for the preparation of KMnO4. In industries, KMnO4 is prepared by alkaline oxidative fusion of MnO2. So MnO2 when undergo fusion with KOH and thereafter oxidized with oxygen or KNO3, so it produces manganate ion, MnO4 minus ion. That is the first step. And in the second step, manganate ion undergo electrolytic oxidation in alkaline solution to produce MnO4 minus, that is permanganate ion. So in this way, in industries, we can obtain permanganate ion in two steps. First of all, manganese dioxide, that is pyrolusite, is fused with KOH in the presence of oxygen or KNO3, that is our first step, which we have seen here also, to produce permanganate ion. And in the second step, electrolytic oxidation is done in alkaline solution. So in alkaline solution, ultimately you will get manganate ion, permanganate ion, MnO4 minus, which is a violet colored solid. Now in laboratory, can we prepare potassium permanganate? For that, we have to use a salt containing Mn2 plus ion, and that salt is treated with persulfate ion. So manganese salt, Mn2 plus salt, is treated with persulfate ion, so it gets oxidized in the presence of acidic medium. So if in the exam, if it is asked to complete this reaction in acidic medium, you have to remember that in acidic medium, Mn2 plus is always getting converted into MnO4 minus. So here we will see that Mn2 plus reacts with persulfate ion. So Mn2 plus should get converted into MnO4 minus, and S2O82 minus, being an oxidizing agent, it will itself undergo reduction to form sulfate ion. So now we have to balance these two equations. In Mn2 plus, Mn is in plus 2 oxidation state, while in MnO4 minus, Mn is in plus 7 oxidation state. So here we can see that this is oxidation reaction. There is a change in oxidation number by 5. So on the right hand side, we have to write down 5 electrons. In persulfate ion, the oxidation number of sulfur is plus 6, while in case of sulfate ion, oxidation number of sulfur is plus 4. Now here we will see that persulfate ion will convert into sulfate ion. So here Mn2 plus will convert into MnO4 minus, persulfate ion will convert into SO42 minus. Now here we will see that on the left hand side, we will take 8H2O. So on the right hand side, we will be having 16H plus, because 8 to the 16 hydrogen are there, so 16H plus. Here we are having 2 time Mn2 plus, so here we will be having 2 time MnO4 minus. And if we take 5 time persulfate ion, so number of sulfur is 5 to the 10, so here it will be 10 times SO4 2 minus. So this is the balanced equation for the laboratory preparation of KMnO4. So manganese salt treated with persulfate ion in the aqueous solution to produce permanganate ion plus sulfate ion plus H plus. Potassium permanganate is a dark purple or almost black colored crystals which are isostructural with those of KClO4. So KMnO4 is isostructural with KClO4, means both are tetrahedral. Okay, both are having the anion, tetrahedral anion. The salt is not very much soluble in water. KMnO4 is just 6.4 gram soluble in 100 gram water at 293 Kelvin temperature. But when heated, it decomposes at 513 Kelvin. So potassium permanganate, when heated at 513 Kelvin, 513 Kelvin, then it decomposes to form potassium manganate along with MnO2 and O2. Thereafter, we will see that there are two physical properties which are very much interesting in case of potassium permanganate, and they are its intense color as well as its dimagnetism. Along with temperature dependent weak paramagnetism. This can be explained by the use of molecular orbital theory. The manganate and permanganate ions are tetrahedral. So if we talk about permanganate ion and manganate ion, that is MnO4 2 minus ion, manganate ion, and permanganate ion, that is MnO4 minus. So here we have to remember that when we are writing manganate ion, it is 2 minus ion. So two oxygen will be negatively charged, so they will be singly bonded. And in case of permanganate ion, only single minus is there, so that means only one oxygen will be singly bonded. So both are tetrahedral, in which the pi bonding takes place between by the overlapping of p orbital of oxygen with a d orbital of manganese. The green manganate is paramagnetic. So green colored manganate ion MnO4 2 minus is paramagnetic, while permanganate ion, because here we will see that in case of manganate ion there is only one unpaired electron, but permanganate is diamagnetic because of all electrons are paired and there is an absence of unpaired electron. So here we will see that in case of MnO4 2 minus, the oxidation number of Mn is plus 6, while in case of Mn the oxidation number is plus 7 in case of permanganate ion. So if we talk about electronic configuration of Mn having atomic number 25, it is argon 4s2 3d5. Now in manganate ion, Mn is plus 6, so 6 electrons are to be removed. So when we remove the 6 electrons, we are remaining with argon 3d1. So because of this unpaired electron, MnO4 2 minus is paramagnetic, while in case of permanganate, Mn is plus 7. So configuration is argon, so that means all the d orbitals and s orbitals are empty, and due to this reason it is diamagnetic in nature. Then we will see that acidified permanganate solution oxidizes the different species. For example, if we take potassium permanganate, so permanganate ion of potassium permanganate can oxidize oxalate ion, that is C2O4 2 minus ion, into carbon dioxide in acidic medium. So in that case, you have to remember that permanganate ion in acidic medium always gets converted into Mn2 plus, and oxalate ion will convert into carbon dioxide. So suppose we have to balance this reaction. So in that case, you have to remember the redox reaction balancing, which we were doing in 11th standard. So here we will see that in rough page you have to balance the equation, and thereafter you have to write in the exam on the main page. So in permanganate ion, Mn is plus 7. In case of oxalate, the oxidation number of carbon is plus 3. In case of Mn2 plus, Mn is plus 2, and in carbon dioxide, carbon is plus 4. Now here we have to balance the underlined elements. So Mn is 1 on both the sides. Carbon over here is 2, so we have to multiply with 2. Thereafter you have to multiply the oxidation number with the number of atoms. So here Mn is 1 only, carbon is 2, so we have to multiply with 2, so it will become plus 6. Mn is 1 only, and here carbon is 2, so we have to multiply plus 4 into 2, so it is plus 8. So here we will see that carbon undergo oxidation from 6 to 8. So there is an oxidation by 2 and there is a reduction by 5. Then you have to multiply both 2 and 5 with a multiple so that both will become equal. So 2 is multiplied with 5 and 5 is multiplied with 2. So in that case, on either sides of this arrow you have to multiply with 2, and either sides of this arrow we have to multiply with 5. So this will become 2 5s are 10. So both the sides are multiplied with 5. Thereafter you have to balance the charges. On the left hand side it is 2 minus and 5 2s are 10 minus, so 12 minus. On the right hand side we are having 2 2s are 4 plus. Now medium is acidic, so on the left hand side we have to add 16H plus, okay, because 16 plus and minus 12 will become plus 4. So both the side it will become plus 4. Then on the left hand side, as we are having 16 hydrogen, so on the right hand side we have to write down 8H2. So this is the balanced equation. Okay, so what is the balanced equation? 2MnO4 minus plus 5C2O42 minus plus 16H plus gives 2Mn2 plus 10CO2 plus 8H2. So this is the balanced equation. Thereafter, the second reaction is the oxidation of ferrous ion. So potassium permanganate can oxidize ferrous ion into ferric ion. So in that case, ferrous ion will get converted into ferric ion, while KMnO4 will itself undergo reduction. So what will be the balanced equation? First of all, we are having manganate ion, MnO4 minus. It reacts with ferrous ion. So manganate ion, permanganate ion in acidic medium is always getting converted into Mn2 plus, and ferrous ion will get converted into ferric ion. So here again by redox only you have to balance the equation. The MnO4 minus plus Fe2 plus gives Mn2 plus Fe3 plus. So here we will see that the oxidation number of Mn is plus 7, iron is plus 2, Mn is plus 2 and iron is plus 3. So here we will see that Fe undergo oxidation by 1 from plus 2 to plus 3, that is oxidation by 1, and manganese undergo reduction by 5 from plus 7 to plus 2. Then we have to multiply with the multiple so that both become equal. So 1 is multiplied with 5 and 5 is multiplied with 1. So wherever this arrow is there, we have to multiply with 5. Thereafter we have to balance the charges. So here total charges 5 2s are 10 and minus 1, so it is plus 9. And on this side it is plus 2 and 5 3 are 15, 17. So on the left hand side we will see that on which side total charge is less. So on the left hand side total charge is less. So we have to add H plus on that side where charge is less. So 5 to the 10 minus 1 is 9. 9 and plus 8 will become 17. So 8H plus. So in that case we have to add 4H2O on the right hand side. So this is the balanced equation. So MnO4 minus plus 5Fe2 plus 8H plus gives Mn2 plus 5Fe3 plus 4H2. So this is the second balanced equation which shows that KMnO4 is an oxidizing agent in acidic medium. Then KMnO4 can also oxidize nitrite ion into nitrate ion. So nitrite ion is NO2 minus. So permanganate ion can oxidize nitrite ion into nitrate ion, and it will itself undergo reduction to Mn2 plus, and nitrite ion will be converted into nitrate ion. So here also we have to balance the equation. So here we will see that MnO4 minus is having Mn in plus 7 oxidation state. In NO2 minus The oxidation state of nitrogen is +3. Then on the right hand side, the oxidation number of Mn2 plus is +2, and oxidation number of nitrogen in nitrate ion is +5. So here there is an oxidation of nitrogen from +3 to +5. So there is an oxidation by 2, and there is a reduction of Mn from +7 to +2 by 5. So here we have to multiply with 2, and here we have to multiply with 5. So wherever this arrow is there, we have to multiply with 2, and wherever this arrow is there, we have to multiply with 5. Then we have to balance the charges. On the left hand side, total charge is 2 minus and 5 minus, 7 minus, and on the right hand side it is 2 to the 4 plus and minus 5, so that is -1. So we have to add H plus on that side where total charge is less, that means on left hand side. On the left hand side we are having -7, on the right hand side we are having -1. So on the left hand side, how many H plus we have to add? 6 H plus, okay, because -7 and +6 will be -1. And on the right hand side, in order to balance hydrogen atoms, for 6 hydrogen we will write 3H2O. So this is the balanced equation. So we will see that the balanced equation is 2MnO4 minus plus 5NO2 minus plus 6H plus gives 2Mn2 plus 5NO3 minus plus 3H2O. Thereafter, permanganate ion can oxidize iodide into iodine. So MnO4 minus can oxidize iodide ion in acidic medium. So in that case, MnO4 minus will form Mn2 plus and iodide will form iodine. So here we will see that in case of MnO4 minus, the oxidation number of Mn is +7. In case of iodide, the oxidation number of iodine is -1. It gives Mn2 plus having oxidation number of Mn as +2 and iodine having oxidation number of I as 0. Now you have to balance the underlying elements. Iodine is 2 times, so you have to multiply with 2. So in that case, this will also be multiplied with 2, so it will become -2. So here we will see that iodide undergo oxidation by 2 and permanganate undergo reduction by 5. So we have to multiply 2 with 5 and 5 with 2. So wherever this arrow goes, we have to multiply with 2. And wherever this arrows goes, we have to multiply with 5. So here 2 is already there. When we multiply with 5, it will become 10. So it will become 10I minus. And this will become 5I2. Then we have to balance the charges. On the left hand side, it is -12. On the right hand side, it is +4. So on the left hand side, we have to add 16H plus. So that 16 plus and -12 will become +4. And in order to balance hydrogen, on the right hand side we have to add 8H2O. So balanced equation is 2MnO4 minus plus 10I minus plus 16H plus gives 2Mn2 plus 5I2 plus 8H2O. So that is the balanced equation. Thereafter, we will see that so till now we have studied those reactions which are occurring in case of KMnO4 with in acidic medium. Okay, some other reactions of KMnO4 with acidic medium are it can convert sulfide ion into sulfur atom. Okay, so if KMnO4 reacts with H2S, then in that case, in acidic medium, KMnO4 will convert into manganese salt such as MnS, and even we will get elemental sulfur. MnSO4 as well as we will get elemental sulfur. So here in case of KMnO4 Mn is plus 7. In case of MnSO4 Mn is plus 2. While here in H2S sulfur is minus 2 and here sulfur is 0. So here we will see that MnO4 minus will undergo oxidation to form Mn2 plus, and sulfide ion of H2SO4 will convert into sulfate. Sulfide ion is getting converted into sulfur atom. Okay, so sulfide is getting converted into sulfur. So we have to balance this equation. So how can we balance this equation? So MnO4 minus of KMnO4 reacts with sulfide ion of H2S to form Mn2 plus and sulfur. So here the oxidation number of Mn is plus 7, oxidation of sulfur is minus 2, oxidation state of manganese is plus 2, and oxidation state of sulfur is 0. So sulfur undergo oxidation by 2, Mn undergo reduction by 5. So this we have to multiply with 5 and this we have to multiply with 2. So it will become 2 MnO4 minus plus 5 S2 minus gives 2 Mn2 plus 5 sulfur. Then on the right hand side we are having total charge plus 4. On the left hand side we are having total charge minus 12. So here we have to take 16H plus. In order to balance this 16H plus we have to take 8H2. So this is the balanced equation. 2 MnO4 minus plus 5 S2 minus plus 16H plus gives 2 Mn2 plus 5 sulfur plus 8H2. Then in acidic medium, permanganate ion converts sulfite ion into sulfate ion. So permanganate ion oxidizes sulfite ion into sulfate ion in acidic medium. That means Mn will get converted into Mn2 plus. So here we will see that oxidation number of Mn is plus 7. Here oxidation number of Mn is plus 2. Here oxidation number of sulfur is plus 4. And here oxidation number of sulfur is plus 6. So sulfur undergo oxidation by 2 and Mn undergo reduction by 5. So you have to multiply this with 5 and this with 2. So it will become 2 MnO4 minus plus 5 SO32 minus gives 2 Mn2 plus 5 SO42 minus. Then we have to balance the charges. On the right hand side total charge is 5 2s are minus 10 and plus 4, so that is minus 6. On the left hand side we are having the charge 2 minus and 10 minus, so 12 minus. So on the left hand side we have to add H plus ion. So minus 12 is there, we have to make it minus 6, so we have to multiply with, add with how many H plus? 6 H plus. Okay, so that on both the side it will become minus 6. Then in order to balance this 6 hydrogen we have to add 3 H2. So this is the balanced equation. 2 MnO4 minus plus 5 SO32 minus plus 6 H plus gives 2 Mn2 plus 5 SO42 minus plus 3 H2. So till now we have studied the chemical property of MnO4 minus in acidic medium. Now we will see the chemical property of KMnO4 in neutral and alkaline medium. So we will see that in alkaline medium or neutral medium, MnO4 minus is always getting converted into MnO2. This you have to remember. Okay. In acidic medium, MnO4 minus was getting converted into Mn2 plus, while in basic and neutral medium, MnO4 minus will get converted into MnO2. So in that, the first reaction is, in alkaline medium, MnO4 minus oxidize iodide into iodate ion. This also we have to remember. In acidic medium, iodide was converted into iodine, while in basic medium, iodide is converted into iodate ion, and permanganate ion is getting converted into MnO2. So we have to balance this equation. Here Mn is plus 7, here iodide is minus 1, here Mn is plus 4, here iodate is plus 5. So iodide gets oxidized from minus 1 to plus 5, so total is plus 6. And permanganate ion undergo reduction from plus 7 to plus 4. So on subtracting it will be plus 3. And here on subtracting plus 5 minus minus 1 it will become plus 6. So here we have to multiply with 2 and here we have to multiply with 1. So here there will be 2, here there will be 2. Now we have to add OH minus. Now you have to remember that OH minus should be added on that side where total charge is more. Okay. So here 2 minus and 1 minus is 3 minus, and here only 1 minus is there. So on this side we have to add 2 OH minus. Then we have to balance these 2 hydrogen of the right hand side by adding H2O on the left hand side. So this is the balanced equation. Second is permanganate ion oxidizes thiosulfate ion, that is S2O32 minus ion, into sulfate ion, and it will itself undergo reduction to form MnO2. So here the charge of Mn is plus 7, charge of sulfur in thiosulfate ion is plus 2, charge of Mn in MnO2 is plus 4, and charge of sulfur in sulfate is plus 6. Now we have to balance the underlined elements. So Mn is 1, here also Mn is 1, here sulfur is 2, so we have to multiply it with 2. Now after balancing, again we have to multiply the charges with the number of atoms. So here number of sulfur atom is 2, so we have to multiply with 2, so it will become plus 4. Here the number of sulfur atom is 2, so we have to multiply 6 with 2, so it will become plus 12. So sulfur undergo oxidation from plus 4 to plus 12, so difference is 8. And Mn undergo reduction from plus 7 to plus 4, so difference is 3. So 8 should be multiplied with 3 and 3 should be multiplied with 8. So they will become 24, 24. So this arrow, wherever it goes, we have to multiply with 8. And wherever these arrows goes, we have to multiply with 3. Now here 2 is already there, we have to multiply with 3, so it will become 6. Then we have to balance the charges by adding OH minus on that side where total charge is more. So here 8 minus and 3 2s are 6 minus, so 14 minus is there, and here 12 minus is there, so 12 minus is more. So on this side we have to add 2 OH minus, so 12 minus and 2 minus will become 14 minus, and so the total charge on both the side become equal. Now in order to balance these 2 hydrogen, we have to add H2O. So now this equation is balanced. Thereafter, permanganate ion can also oxidize manganese ion. So that is the third reaction, and this reaction is present in neutral medium. So in neutral medium, permanganate ion will get converted into manganese dioxide, and Mn2 plus ion will also get converted into manganese dioxide. So here we can see that permanganate ion, which was in plus 7 oxidation state, will undergo reduction to MnO2 with plus 4 oxidation state, and Mn2 plus, which was in plus 2 oxidation state, gets oxidized to MnO2 with plus 4 oxidation state. So here permanganate ion undergo reduction from plus 7 to plus 4, so that is by 3. Okay, difference is 3. And manganese ion, which was in plus 2 oxidation state, has converted into plus 4, so that means oxidation by 2. So 2 has to be multiplied with 3 and 3 has to be multiplied with 2, so both become 6, 6. So wherever this arrow goes, we have to multiply with 2. Wherever this arrow goes, we have to multiply with 3. Thereafter we have to add required charge. So on the left hand side it is minus 2 and plus 6, so it is plus 4. On the right hand side there is no charge, so on the right hand side we have to add 4H plus, so both the side become plus 4 plus 4. So this is our, now in order to balance this 4 hydrogen we have to add 2H2O. So you can even add the same species together. So either you can keep the balanced equation like this only, or you can also write it like this: 2MnO4 minus plus 3Mn2 plus 2H2O arrow. Now here 2MnO2 is there, here 3MnO2 is there, so total is 5MnO2 plus 4H plus. So in this way you can add the same species together also and can write down the balanced equation. So this is our balanced equation. Now let us see uses of KMnO4. So first use is in analytical chemistry. So KMnO4 is used in analytical chemistry, that is for titration as an oxidizing agent. Second use is it is used as an oxidizing agent in organic chemistry. So it is used as an oxidizing agent in organic chemistry. Then it is used for bleaching of wool, So woolen clothes can be bleached, then cotton fabrics can be bleached, silk and other textile fibers. So for bleaching of the textile fibers we can use KMnO4. Then fourth use of KMnO4 is for decolorization of oil, for decolorization of oils. So as we know that KMnO4 is an oxidizing agent, so it can decolorize the oil due to its strong oxidizing power. That's all for today.